Have you ever looked up at the night sky and wondered, just how big is the universe? It's a question that has captivated humans for centuries. We gaze at the stars, points of light scattered across the vast canvas of space. Our curiosity is ignited. We yearn to comprehend the sheer scale of it all. Prepare to be amazed. The universe is filled with wonders that defy imagination. Our journey begins right here at home on planet Earth. It's a sphere of life, a blue oasis in the vastness of space. Yet, in the grand scheme of the universe, it's but a tiny speck. Our Earth and Moon are part of the Sun's family, called the Solar System. The Solar System, though vast by our standards, is but a tiny part of the Milky Way galaxy. Imagine shrinking our entire solar system down to the size of a grain of sand. That's how vast the Milky Way is. Billions of other galaxies populate the observable universe. These galaxies are clumped together in groups called galaxy clusters. The universe is a tapestry of interconnected structures, a cosmic web of matter and energy. From the vast expanse of space, Earth appears as a pale blue dot, a tiny speck of life in the cosmic ocean. It's a humbling perspective, reminding us of our planet's fragility and our responsibility to cherish it. Our planet is a marvel, a delicate balance of land, water and atmosphere teeming with life. But despite its apparent vastness, Earth is dwarfed by the immensity of space. The average distance between Earth and the Moon is about 238,900 miles. The Moon orbits Earth in an elliptical path, meaning its distance from us varies slightly over time. At its closest point, known as perigee, the Moon is about 225,623 miles away. At its farthest point, apogee, it's about 252,088 miles away. The Moon's gradual drift is a reminder that the universe is a dynamic and ever-changing place. Our planet is a remarkable celestial body. With a diameter of approximately 7,917 miles, Earth is the largest of the 4 inner rocky planets in our solar system. Earth's atmosphere is another crucial factor that makes life possible. One of Earth's most defining features is its abundance of liquid water. Earth's rotation on its axis gives us day and night, while its orbit around the Sun determines our year. As we leave the familiar confines of Earth and its lunar companion behind, we embark on the next leg of our cosmic journey. The Sun, a blazing ball of fire at the heart of our solar system, holds the planets in its gravitational embrace. The distances between planets are staggering. The emptiness of space is one of its most striking features. Our journey through the solar system is a humbling reminder of the vastness of space and the relative insignificance of our planet. Our Sun. A giant ball of blazing hot gas, a churning inferno that dictates the rhythm of our solar system. The Sun is immense, with a diameter about 109 times that of Earth. Deep within its core, hydrogen atoms fuse together under unimaginable pressure, releasing a tremendous amount of energy. This energy radiates outwards, bathing the planets in light and heat. Our journey through the solar system begins with the inner planets. Mercury, the smallest planet in our solar system, is a world of extremes. Venus, often called Earth's twin due to its similar size and mass, is a cautionary tale of a runaway greenhouse effect. And then there's Mars, the red planet. These inner planets offer a glimpse into the diverse range of planetary environments that exist within our own solar system. Past the rocky terrain of the inner planets lies a realm of gas giants: Jupiter, Saturn, Uranus, and Neptune. Jupiter, the largest planet in our solar system, is a true behemoth. Saturn, the ringed planet, is a celestial beauty. Uranus, the ice giant, is tilted on its side with its axis of rotation nearly parallel to its orbital plane. Neptune, the farthest planet from the Sun, is a world of deep blue hues. Our journey through the solar system takes us beyond the realm of the gas giants to the Kuiper Belt, a vast and icy region of space that lies beyond the orbit of Neptune. This region is home to countless icy objects, remnants from the early solar system. These icy wanderers, some no larger than pebbles, others hundreds of miles across, hold clues to the formation and evolution of our solar system. Pluto, once considered the ninth planet, resides in the Kuiper Belt. Reclassified as a dwarf planet in 2006, Pluto is a fascinating world of its own, with a heart-shaped glacier and a thin atmosphere. Pluto's demotion sparked debate and highlighted the evolving nature of our understanding of the solar system. The Kuiper Belt is thought to be the source of many of the comets that grace our skies. These icy wanderers, nudged out of their orbits by gravitational interactions with the outer planets, embark on long, elliptical journeys around the Sun. As they approach the Sun, the heat vaporizes the ice, creating the characteristic tails that streak across the night sky. Beyond the Kuiper Belt lies the Oort cloud, a vast and spherical shell of icy objects that is thought to extend halfway to the nearest star. This region, still largely theoretical, is thought to be the source of long-period comets, those that take thousands or even millions of years to complete a single orbit around the Sun. We've journeyed from our pale blue dot past the fiery heart of our solar system to the icy outskirts of the Kuiper Belt. Now, we shift our gaze to the Milky Way, our galactic home. Imagine shrinking our solar system to a grain of sand. The Milky Way would be a giant city of stars. It's a barred spiral galaxy, a majestic swirl of stars, gas, and dust. We reside in one of its spiral arms, far from the bustling center. Looking up, we see the Milky Way as a band of faint light. Finding our place in the vast stellar metropolis can seem daunting, but astronomers have pieced together our cosmic address. We reside in the Orion Arm, a minor spiral arm of the Milky Way. It's like living in a suburb of a bustling city. Our solar system orbits the Milky Way center every 230 million years. The last time our sun was here, dinosaurs roamed the Earth. Our solar system bobs up and down as it orbits. From the Orion Arm, we have a front row seat to the galactic show. The Milky Way, like most spiral galaxies, possesses a distinct structure. Imagine a fried egg sunny side up. The yolk of the egg represents the galactic bulge, a spherical region at the center of the Milky Way, densely packed with stars. This bulge is thought to harbor a supermassive black hole, a gravitational monster millions of times more massive than our Sun, lurking unseen at its heart. Extending outward from the bulge are the spiral arms, those graceful arcs of stars, gas, and dust that give spiral galaxies their distinctive appearance. These arms are not static structures like the spokes of a wheel. Instead, they are thought to be density waves, regions of higher density that propagate through the galaxy, much like ripples on a pond. As these density waves sweep through the interstellar medium, they compress the gas and dust, triggering the formation of new stars. This is why spiral arms are often regions of intense star formation, illuminated by the brilliant light of newborn stars and glowing nebulae. The Milky Way's spiral arms are also home to a variety of other objects, including star clusters, planetary nebulae, and supernova remnants. Star clusters are groups of stars that form together from the same cloud of gas and dust. Planetary nebulae are the glowing remnants of dying stars, their outer layers expelled into space in beautiful, intricate patterns. Supernova remnants are the expanding debris clouds from exploded stars, seeding the interstellar medium with heavy elements that will one day be incorporated into new stars and planets. While the birth of stars is a spectacular event, the death of a star can be even more dramatic. When massive stars exhaust their nuclear fuel, they can no longer support themselves against their own gravity, and they collapse in on themselves. This collapse triggers a supernova explosion, a blinding flash of light that can briefly outshine an entire galaxy. The remnants of these stellar explosions are scattered throughout the Milky Way, like cosmic tombstones marking the final resting places of stars. Some of these remnants are neutron stars, incredibly dense objects composed almost entirely of neutrons. These stellar corpses are so dense that a teaspoonful of neutron star material would weigh billions of tons. Other supernova remnants harbor black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape. Black holes are invisible to telescopes, but their presence can be inferred from their gravitational effects on nearby stars and gas. The supermassive black hole at the center of the Milky Way, for example, is thought to be millions of times more massive than our Sun, its immense gravity holding the entire galaxy together. These stellar remnants may seem like endpoints, but they are also part of the ongoing cycle of stellar birth and death. The material ejected from dying stars enriches the interstellar medium with heavy elements which will eventually be incorporated into new generations of stars and planets. In a very real sense, we are all made of star stuff. When we gaze at the Milky Way, we are not just seeing a snapshot of the present, we are looking back in time. Light from distant stars takes time to reach us, so the farther away a star is, the younger it appears to us. The light we see from stars on the opposite side of the Milky Way, for example, left those stars tens of thousands of years ago. This means that by studying distant objects in the Milky Way, we are effectively looking back in time, observing the galaxy as it was billions of years ago. This allows astronomers to piece together the history of our galaxy, from its formation in the early universe to its present-day structure. The Milky Way is not alone in the universe. It is just one of billions of galaxies that populate the observable universe. And just like stars are grouped into galaxies, galaxies themselves are clustered together into groups and clusters, forming a vast cosmic web of interconnected structures. But that's a story for another time. For centuries, our understanding of the universe was confined to the Milky Way. It was our entire cosmos, a solitary island of stars in the vast ocean of space. But in the early 20th century, astronomer Edwin Hubble made a groundbreaking discovery. He observed faint patches of light that were entire galaxies far away. The universe was an archipelago of countless galaxies, each with billions of stars. These galaxies come in a variety of shapes and sizes. Some, like our own Milky Way, are spiral galaxies. Others are elliptical galaxies, and then there are irregular galaxies. Imagine standing on a beach gazing at the vast ocean. Each island on the horizon represents a galaxy. Some islands are large and imposing, others are smaller and more subdued. The discovery of galaxies revolutionized our understanding of the universe. It revealed a cosmos far grander and more diverse than we had ever imagined. But it also raised profound questions. How many galaxies are there? How did they form? And what is their ultimate fate? Stars group into galaxies, and galaxies form clusters. Our Milky Way is part of the Local Group, a collection of about 54 galaxies. The Andromeda Galaxy, 2.5 million light-years away, is the largest member. Andromeda contains 1 trillion stars and will collide with the Milky Way in 4 billion years. The Local Group includes diverse galaxies, from large spirals to small dwarfs. Astronomers study it to understand galaxy formation and dark matter. The Local Group, though vast by our standards, is just a tiny speck in the grand scheme of the universe. Galaxies are not just grouped together in small groups like our own, but also in massive clusters, containing hundreds or even thousands of galaxies, all bound together by gravity. These galaxy clusters are among the largest structures in the universe, spanning hundreds of millions of light-years. One such galaxy cluster, the Coma Cluster, located about 320 million light-years away, contains thousands of galaxies, a swarm of island universes bound together in a cosmic ballet of gravity. At the heart of the Coma Cluster lies a pair of giant elliptical galaxies, their cores blazing with the light of billions of stars. But galaxy clusters themselves are not the end of the story. They, in turn, are grouped together into even larger structures known as superclusters, vast filaments and sheets of galaxies that stretch across billions of light-years. These superclusters are connected by filaments of galaxies, forming a vast cosmic web, like a giant spider web spun across the universe. The discovery of this cosmic web has revolutionized our understanding of the large-scale structure of the universe. It suggests that galaxies are not randomly scattered throughout space, but are instead arranged in a complex, interconnected network, shaped by the gravitational forces of dark matter. Our journey through the universe has taken us from our humble home on Earth to the vast expanse of the cosmic web. We've encountered scales that defy our everyday intuition, from the unimaginable distances between stars to the mind-boggling number of galaxies that populate the observable universe. Yet despite all that we've learned, the universe remains a place of profound mystery. We still don't fully understand how galaxies form and evolve, what dark matter is made of, or whether there is life beyond Earth. But one thing is certain: the universe is full of surprises, and each new discovery serves to deepen our sense of awe and wonder. As we continue to explore the cosmos, we are driven by a deep-seated curiosity, a desire to understand our place in the grand scheme of things. The universe is a vast and mysterious place, but it is also a place of incredible beauty and complexity. By studying the universe, we are not just unraveling the secrets of the cosmos, we are also learning more about ourselves and our place in the grand tapestry of existence. We've traversed the vast expanse of the Milky Way, ventured beyond our galactic shores to encounter a universe teeming with galaxies, and marveled at the intricate cosmic web that connects it all. But even as we gaze out at this grand cosmic tapestry, we encounter a profound limit, a boundary beyond which even the most powerful telescopes cannot see. This boundary is the cosmic horizon, the edge of the observable universe. The cosmic horizon is not a fixed boundary in space. As the universe ages, the cosmic horizon expands, revealing the universe's distant past. It's like watching a movie in reverse, unveiling new frames from the early universe. Light from these objects carries information about the early universe. The cosmic microwave background provides a snapshot of the universe after the Big Bang. This afterglow helps us understand the early universe's conditions. Studying quasars reveals the evolution of galaxies over cosmic time. These cosmic beacons shine from the early universe, their light stretched by expansion. Observing quasars helps us study the intergalactic medium. The farther we peer, the closer we get to the moments of creation. The cosmic horizon reminds us there's much more to discover. For centuries, astronomers believed that the universe was static and unchanging. But in the 1920s, Edwin Hubble discovered that distant galaxies are moving away from us. This led to the conclusion that the universe is expanding. Imagine baking a loaf of raisin bread. As the bread bakes, it expands and the raisins move apart. The same thing is happening in the universe. The galaxies are like the raisins, and the dough is space-time. The observable universe is just a tiny fraction of the entire universe. What lies beyond our cosmic horizon? We can only speculate. Some theories suggest the universe is infinite, others propose it is finite but unbounded. The nature of dark matter and dark energy remains one of the biggest unsolved mysteries. Answering these questions requires new telescopes and new ways of thinking. The search for life beyond Earth is another compelling frontier. We are driven by a profound sense of wonder and a desire to understand our place in the universe. As we conclude our cosmic journey, we find ourselves back where we started, on our tiny planet under a vast and star-studded sky. Yet we are forever changed by the experience. We have glimpsed the unimaginable scale of the universe, from the familiar confines of our solar system to the distant shores of the cosmic horizon. We have encountered objects and phenomena that challenge our understanding of the very laws of physics. The universe, we have learned, is not a static, unchanging backdrop to our existence. It is a dynamic, ever-evolving entity, a cosmic dance of creation and destruction, of expansion and contraction, of order and chaos. Stars are born in the fiery crucibles of nebulae, live out their lives for millions or billions of years, and then die. Sometimes in spectacular supernova explosions that seed the interstellar medium with the building blocks of new generations of stars and planets. The vast distances involved in astronomy can make it seem like a remote and abstract science. But the universe is not something separate from us. We are a part of it, connected to it by the very atoms in our bodies. The iron in our blood, the calcium in our bones, the oxygen we breathe. All were forged in the hearts of stars that lived and died long ago, their remnants scattered across the cosmos, eventually coalescing to form our planet and everything on it. The study of the universe has a humbling effect. It reminds us of our own insignificance in the grand scheme of things. Our planet, for all its beauty and diversity, is but a tiny speck of dust orbiting an ordinary star in an unremarkable galaxy among billions. Our lives, spanning mere decades, are but fleeting moments in the cosmic timescale. But this realization should not fill us with despair. On the contrary, it should inspire us. Despite our smallness, we have evolved to contemplate the very universe that birthed us. We have developed the tools and the intellect to study the cosmos and uncover its secrets. We have sent spacecraft to explore the planets, peered into the hearts of galaxies, and detected the faint afterglow of the Big Bang itself. The cosmic perspective teaches us to appreciate the interconnectedness of all things. The atoms in our bodies were once part of stars that exploded billions of years ago. The water we drink, the air we breathe, the very ground we walk on, all were formed from the remnants of these ancient stellar explosions. We are, in a very real sense, children of the cosmos. The universe is full of mysteries, and each new discovery raises more questions than it answers. What is the nature of dark matter and dark energy, the unseen forces that govern the evolution of the universe? Are there other universes out there, perhaps with different laws of physics? Is there life beyond Earth, and if so, what forms might it take? These are just a few of the questions that drive astronomers and cosmologists to continue exploring the cosmos. The search for answers is a never-ending journey, but it is a journey worth taking. For in seeking to understand the universe, we ultimately seek to understand ourselves. So the next time you find yourself under a clear night sky, take a moment to appreciate the vastness of the universe and the countless wonders it holds. Let your curiosity guide you and never stop exploring the cosmos, both within and beyond.